Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Practical Agent Design Patterns. Strategies for Reliable AI Agents. Imagine you have a super smart, digital helper that can understand what you want, figure out how to do it, and then actually do it. That's essentially an AI agent. Think of it like a personal assistant on your computer. Instead of just following exact instructions, like a regular program, an AI agent can perceive its environment, like seeing a messy inbox, decide what to do, like thinking to prioritize urgent emails, and then act on it, like sending a reply or scheduling a meeting. As developers, we're building these intelligent helpers to automate complex tasks, making our applications smarter and more useful. When you build a house, you don't just start nailing planks together randomly, right? You use blueprints and established building techniques. In software development, design patterns are like those blueprints for common problems for AI agents. They're pre-tested, proven ways to structure your agent's brain and behavior, so it's reliable, understandable, and easier to build and improve. Instead of writing a tangled mess of code every time, design patterns give us a clear roadmap. This is especially crucial for AI agents, where things can get complex very quickly, and we need our agents to be predictable and dependable. This is the fundamental cycle for almost any AI agent, like a constant heartbeat. 1. Perceive. The agent looks at its environment. What's happening? E.g., I see a new email in the inbox saying urgent. Single quote. As a developer, this means your agent collects information from databases, user input, APIs, or sensor data. 2. Think, decide. Based on what it perceived and its goals, the agent thinks about what to do. E.g., this email is urgent. My goal is to respond quickly to urgent emails. I should draft a response. This involves your agent processing information, perhaps using an AI model, like an LLM for language understanding, to reason. 3. Act. The agent performs an action. E.g., I will draft the email response and send it, or flag it for human review. This translates to your code executing functions, calling external tools, or updating data. Then, the loop starts again. This simple, continuous cycle is how an agent interacts with the world and achieves its goals. Imagine you're building a complex software project. You wouldn't have one person do everything from design to coding to testing, right? You'd have a team with specialized roles. A designer, a developer, a tester. The role-playing agent pattern applies this concept to AI. You create multiple smaller AI agents, each given a specific persona or role with clear instructions and goals. For example, one researcher agent might scour the internet for information, a summarizer agent might condense it, and a writer agent might draft a report. As a developer, you define these roles and how they communicate, making complex tasks manageable and more reliable because each agent focuses on what it's best at. Think about how a chef tastes their dish before serving it, or how you review your homework before handing it in. This is reflection. In AI, the reflection and self-correction pattern means giving your agent the ability to look back at its own work, identify potential errors or improvements, and then adjust its approach. For instance, after drafting an email, an agent might reflect by asking itself, does this sound professional? Is it clear? Does it answer the user's question fully? If it finds an issue, it then self-corrects by revising the draft. As developers, we build in these feedback loops, often by prompting an AI model to critique its own output based on certain criteria, leading to much more robust and trustworthy agents. An AI agent, by itself, is powerful, but imagine giving it superpowers by allowing it to use external tools. Just like a human uses a calculator, a map app, or a web browser, the tool use agent pattern is about enabling your AI to interact with other software systems. For example, an agent might decide it needs to search the web for current stock prices using a search API, or send an email using an email API, or create an event on your calendar using a calendar API. As a developer, you provide the agent with a list of available tools, functions you've written, and teach it when and how to use them. This vastly expands what your agents can do, moving beyond just text generation to real-world actions. So, how do these patterns make agents reliable? The *perceive act loop * provides the fundamental operating system. Role-playing * makes complex tasks manageable by breaking them into specialized parts. Like a well-oiled team, reflection and self-correction * ensures quality control, allowing agents to learn from their outputs and refine their actions. Catching errors before they become problems * tool use * expands the agent's capabilities, letting it interact with the real world beyond just its internal brain. By combining these patterns, you, as a developer, aren't just coding a script, you're engineering a truly intelligent, dependable, and capable digital assistant that can tackle sophisticated challenges with confidence and consistency. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.